right, welcome back. This is our last lecture. Next Monday, we will go over the practice exam. I will have it posted either tonight or tomorrow morning. I suspect it's going to be tomorrow morning. I'm finishing it up. So I recommend trying to do it this weekend on your own. See how well you do, see how well you prepared are. There will be a little bit of stuff from each chapter, including 19, but not very much from 19.
So how many questions are we gonna have on the test?
I think I did 20 or 25. I don't know. It's like they've all been.
Last time.
Yeah, I've been pretty consistent with that.
First one, I think it was.
The less I have to do, the less I have to grade. The less I make, the less I have to grade. But the less I make, the more each question hits your grade if you get it wrong. So I try to make a variety of questions. That way, you know, you can, if I have 10 questions and you miss one, you're down to 90%. If I have 20 questions and you miss one, you're down to 95%. You can miss two and still get an A. So the more questions is the better for students. All right, so trigonometric functions. These are with in regards to writing right triangle functions. So I will call the top A, point B over here, and point C down here. That makes this little side here A, this side over here B, and this side here C. If I am looking at angle A, from angle A, we have three functions. Well, these functions exist for all of them. Let me just write the formulas for them, and then I'll show what they mean from angle A. We can have sine of the angle, sine of theta, which reads sin, but it's really spelled sine, is opposite over hypotenuse. And I'll identify all of these three things in a second. Cosine of theta is adjacent over hypotenuse, and tangent theta is opposite over adjacent. This is sine, cosine, and tangent. And those letters are short for OPP is opposite. ADJ is adjacent, which means next to. And HYP is hypotenuse, which is the side opposite of the right angle. Or the 90-degree angle. From angle A's perspective, the opposite side is A. The adjacent side is the side touching it that is not the hypotenuse. I'm going to add that to the description of adjacent. Next to, but not the hypotenuse. Angle A is touching both sides C and both B. C is the hypotenuse, so B is the adjacent side. And the hypotenuse is C. This changes if I look at from angle B. If I do angle B right here, opposite is B, adjacent is A, and hypotenuse is still and always C. So if I look at that, if I try to mesh this up with what these functions are here, I have the sine of A is opposite, which is little a, over hypotenuse, which is C. Cosine of A is adjacent, which is B, over hypotenuse, which is C. And tangent of A is opposite over adjacent. A over B. And so they will usually say this, instead of putting theta or something like that, they will put the letter of the point where the angle is coming from. So A, this is angle A. That is angle A. And this angle is angle B. B. If I look at sine of B, I need to follow this pattern, opposite, which is B, over adjacent, which is C. Cosine of B is adjacent, which is A, over hypotenuse, which is C. And tangent of B is opposite, which is B, over adjacent, which is A. You'll notice that these relationships hold. Cosine of A is the sine of B, and the sine of A is cosine of B. Which is kind of neat. All right, so those are three formulas, and they can be a pain in the butt to memorize. So what is a convenient way of memorizing those three functions? I'll just write them down again, and I'll show you how a lot of people do it. I wanted to slap the shit out of the author of the book when I saw what they put. Okay, so the way they do it is they take the first letter of each thing S for sine, O for opposite, and H for hypotenuse, SOH. C for cosine, A for adjacent, H for hypotenuse, CAH. T for tangent, O for opposite, A for adjacent, TOA. So it's pronounced so, ka, to, maybe. I don't know how you write phonetically. Ka. No one says ka. They don't say so ka to.
It's like,
They say so ka, because
so
they do it so it rhymes with to so ka to. So it kind of rhymes. So ka to. It rhymes. So ka, that's the phonetically how it sounds. So ka. I don't know how you write maybe K-A? Ka?
Yeah, no, that's still ka.
This looks like ka, all right.
Yeah.
Ka? That looks better than CUH. There's an with a K. Well, the point is, memorize the sound and you'll be able to write it down. And until you have it memorized, just by these, just say it, write it down when you need it. Let's take a look at how it's used. Let's say I have a triangle. These need to be right triangles. It's important. This works with right triangles. Let's say this is 7 inches, this is 2 feet, and this is 2 feet 1 inch. Well, I want them all in the same units, so get them in the same units first.
Yep.
What, 20 minutes later, instead of going to class? Don't look at me like that.
Sorry, it was like due today and I needed.
That's why you do it before the day it's due. So she hasn't had it the entire rest of the semester, any other day.
She's been busy, she's been out in the barn. You can ask for herself.
Yeah, it's how it's vicious. It's due today, and she has had no time the entire semester to do it, except for during my class. I will, what's her name? Which professor is it? No, you don't want me to ask her? Because I'm about to call bullshit on this. It's okay, I'm just heckling you. You told me you were here. So I knew you were here and not here, you blame me.
What the?
I knew you were not coming to class because
I said she's checking in on another teacher. That's responsible.
that's what he did tell me you were doing that. That doesn't,
That's responsible. She
I
checking
don't know
in.
what it is.
but she's doing it in my class, which means my class is not, it's my class isn't
At
important.
least we had cake.
You what?
Yeah, I don't think anyone else
Crickets.
That's a good point. You have a good point. Now get your shit out and start taking notes.
I'm trying.
All right. So we want to get them in the same units first. I think it's easiest to get these down in inches. So how do I convert 2 feet to inches? Oh, this should take you back to the beginning of the semester.
It's a 1 inch is 12. No, 1 foot is 12 inches, right?
1 foot is 12 inches. So let's make our bridge. We've got inches. 1 foot is 12 inches. So we want to get rid of feet. So we're going to put that on bottom and we'll put the inches on top. So when I multiply it over, feet cancel out, and I have 2 times 12 is 24 inches. Well, if 2 feet is 24 inches, how many inches is 2 feet and 1 inch? Without reinventing the wheel,
25 inches.
it's 25 inches. If you know this is 24 inches and this is 1 inch more, this is 25 inches. So I will redraw that picture. I'm gonna redraw that picture on another page.
You know, so close to, telling my professor how much, the bottle of Sine, because I still want to. And, she was too late.
My math teacher wants to know.
Yeah.
He's a sick fuck. All right, let's redraw that triangle with the units we have. We've got 7 inches, we've got 24 inches. And we've got 25 inches over here. So if I want to do sine here, sine of theta is, let's call this, I'm going from that angle right there. Sine of theta is opposite over hypotenuse, SOHCAHTOA. Let's write that down again here where we can see it. SOHCAHTOA. Sine is opposite over hypotenuse. Opposite from this side is 7. And hypotenuse is always the longest side, is 25 inches. So sine of theta is 7 over 25. Notice that the units cancel out. There are no units on this. Cosine of theta is adjacent over hypotenuse. The side adjacent to theta that isn't hypotenuse is the 24. So I have 24 over 25. So that's cosine of theta. Then we have tangent of theta equals opposite over adjacent. TOA, opposite, adjacent. Opposite is a 7, adjacent is a 24. Here, we don't have the what angle, we don't know what angle it is. We don't know what theta is. But we can figure it out with a calculator. There are 3 people on Zoom. It's about right.
What's his name? Don't come on.
No, and he's not on today, normally he is. Yeah. Okay, so how do I do it on a calculator? I don't know if you guys can see this very well. My calculator, let's see if I can hold it up where you can see it. Motherfucker.
There you go. You can see it right there.
It's above, there it is. See where it says SIN?
Yes.
Right above it, there's a SIN with a -1. So generally, calculators have 2 buttons. Well, there's one for each of these. Many calculators have a button for sine, cosine, and tangent. And above them, they say this. This is usually, what's above it is usually. Above is done with a shift key or something like that. Depending on the calculator. To find angles. You do the -1 side. Hit shift. Or mode or whatever it is, alpha or whatever the button is. Then the appropriate. Angle button. And enter. What the sides are.
It should.
Okay, hit shift. Then.
Yeah.
The appropriate angle.
Hit shift, then the appropriate angle button and enter what the sides are. I'll show you. What are you laughing about? Do you have a shift on yours? I think you have the same calculator as mine. Looks
No, I
similar.
think mine's better.
Is it really? Is that what you're going with? Yours is better. Yours is a piece of shit.
No, mine can go back.
Excuse me?
No, go
Mine
back.
is probably.
The same.
No, it's got I see it got history on it.
I don't
Is
want
that really better?
I don't want that either.
Yeah, see.
See that?
It's only better if you fucking have any skill in using a calculator.
I do.
Clearly, I can see you're tried 6 times to enter 5275 right there.
No, I told you I don't want the number. I can delete it through.
Oh, I can delete too. Look,
Why is this yours like all blurry?
if you have bad vision.
That's a lot.
I said fine. She got jokes. Is that blurry? She got jokes.
No.
All right, so I'm gonna show, I'll write down what I'm doing here. I'm gonna hit shift. And then I'm gonna hit the sine button. Because I'm going for sine inverse. And then I'm gonna hit, I've got a parenthesis key.
Yeah, I do too.
I'm gonna hit the left parentheses key. I'm gonna hit 7. Then divided by 25, which is the sine.
So, 2 parentheses or 1?
1.
Because it, the sin comes in with 1.
If it already has the parentheses, don't do it.
Oh,
So. If it generates parentheses. You don't need to add those.
okay. Do I enter it?
Yeah,
I got 16.26020471.
we'll see if I get the same thing.
Good.
I will. Fucking relax a second. Jesus, Mason. Fucking over here rushing my ass. Trying to let people write it down, and then I'm gonna do it on the screen as an instructor, walk you through it. I'm gonna hit, my shift key is here, I'm gonna hit that. Do I have a parentheses pop up? I do not have a parentheses pop up, because my calculator is inferior. 7 divided by 25, end parentheses. I got it the way I exactly want it? Yes, I do.
I see it as 8. Oh, what'd you get? 16.2602.
I got 16.26. Do you want all the decimal places mine shows? So sine inverse of 7/25 is, it looks like sin, but it's pronounced sine. 16.26020471. In fact, I recommend writing down as many as your calculator shows for like later steps when we use it in problem solving. because you don't want to round until your very end. We should get the same thing if you do cosine inverse of its value. Notice it, recall its value was 24/25. I'm going to do cosine inverse of 24/25, and I'm going to do tangent inverse of 7/24.
Let's see here. See, it comes with some parentheses.
I got the 16.26020471 again.
Yep.
And when I do shift tangent inverse. $16.26020471 again. The reason why is when we do this, what we're doing is we're telling it find the angle. This is what this top one says. Find the angle that makes (7/25) when we use the sine of that angle.
What's
Sine, S-I-N-E.
You ever looked at toes back with the guns?
What?
You ever looked at toes back?
No.
No? One of those magic toes?
I've done a lot of things that have produced hallucinogenic effects, but fucking looking at animals is not one of them.
Wait, what?
There are some toads that the back of their back secretes something that triggers a hallucinogenic effect.
People will lick them and they start hallucinating.
If you ingest
No, they
it.
pick up.
So people will pick up these fucking toads and lick
Yeah,
it.
a toad, yeah.
And Nate is fucking pulling an Ari on me right now. He's fucking trying to.
I was just curious, just popped in my head.
Oh, you make it already.
And so what it's doing is telling me find theta. That's what it's doing. Each of these is saying find theta. So this is actually if I rounded it, this is 16.26 and it's probably in degree mode. Because there's no way it's going to give me that in radians.
It's degrees, oh, yeah.
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 Most calculators have a way to shift between degree and, let me see if I can find the right setting. There we go, right there. I have a mode button right here. If I hit mode and if I hit mode again,
Oh,
I hit mode twice and I get degree, radian, or the third one is gradients, which is well beyond the scope of this class. I can shift to radian mode by hitting 2.
wait. So I went to mode, and then I have comps.
And hit mode again.
It went straight to putting in an equation.
You hit mode twice in a row? Then I don't know how yours works. I have to look at it later. They might have a different way later. Not train wrecking class to show you.
Right? I'm just trying to figure it out.
Swear right now, and I'll show you later. Lecture time. So. Did everyone on Zoom, was able to find this on their calculator? Figure out how to use it's called inverse function, sine inverse.
Not me because I don't have a calculator.
No, you have one of those
Yeah.
rocks and like something to carve the rock with, and yeah, she's got this archaic fucking thing.
Is it the horizontal one?
She's got, it's literally just the 10 digits, plus minus, multiply, divide, equal, there's a clear on it. And I'm pretty sure there's like an M plus and M minus for memory and 2 other buttons. She's got this, and it's hella big. It's like half the size of this paper. It's for old people.
Taxes and stuff?
No, old people or people that do taxes have one that has, it's similar setup, but they have one that's got a ribbon on it. Like a receipt wheel, so that they can just keep doing it and have a history on paper of what it is.
Like a typewriter.
Yeah, it's like it's called a 10 key, but it is like a typewriter for calculators. If I, without anything else to call it,
Right?
what?
That's a good analogy, right?
Yeah,
Y'all looking at me like,
because it's not quite, because you have to keep putting paper into the typewriter and this thing just has a roll
Yeah,
of paper.
redo.
It's more like having a typewriter with a toilet paper roll on it, and it feeds the toilet paper through.
that's
All
a
right.
good one. That's a good one, Jones.
Everything I say is a good one.
Well,
We can go the other way too.
too confident.
We can have an angle. And find at least the decimal values of their ratio. So like if we do sine of 72 degrees. Sine 72. I never switched to radian mode.
Oh no, it's over.
And I get 0.951056.516. If you don't know. Yes,
Did you put in the degree sign?
no, just the sign, the number. You can see what I put in. Because my thing has a history also. It's not that old. It shows sine 72. There's no degree symbol on there. If you don't know if your calculator is in degrees or radians.
I think you broke my calculator.
I didn't touch your calculator.
Cause I put sign and put 72 frequencies and it says match error. Cancel, go to,
Hit clear, try it again. Don't hit any parentheses keys.
there's no clear on this.
There's a fucking, I guarantee there's a clear button on there. Off will work. AC or C works.
Okay, look. Well, not.
Don't hit parentheses at all. Just hit sign, the sign key, hit 72 and hit equal.
Not even the other parentheses?
No, because yours automatically did it. You told me that.
Yeah, but it's only one parentheses.
Just try hitting equal and seeing if it works. Did it not work?
CNA.
Cancel, that's here, it's not there.
So try hitting the parentheses.
You already wrote it down.
Yeah, that's where I'm. And then
And,
72. And. Try parentheses.
Try ending, doing the end of parentheses. Just bring your fucking calculator here. There's no, it's quicker to just do this, let her do this rather than derail.
let's figure it out.
No, you've got inverse going on. That's the problem.
What? I got what going?
You were doing you did the shift one. Just do the regular one. Notice I don't have a -1 here. I have it up there.
Oh, that makes more sense, Joan.
It is, it does. It was a user error, not a calculator error.
Good job, Joan.
That's right. I'm fucking really good at what I do. So check it out. If you don't know if your calculator is in degrees or radians, this is an easy test. Put in sine of 30 like that. If you get 0.5, you are in degrees. That's an easy test.
It's 5, or it's in 0.5.
Yes. Because if it's in radians, it won't give it to you.
I'm gonna do it. Yep, 0.5. Hey. You know that slow-mo, like. You know?
Yeah. Okay, let's do another triangle and let's look at the triangle and figure out what the sine, cosine, and tangent are by looking at it. And then we'll talk about 3 more functions. Let's do 4, 12. And 12.65.
Inch?
Sure. Why not?
Yeah, I've got letters on here too.
You shouldn't need the letters for this. We just use the letters to represent the triangle, but you don't need the letters for the calculator work.
Yeah, but I'm just saying.
So the sine of theta is opposite. I gotta put a theta. Let's put theta on A. Opposite over hypotenuse. So SOHCAHTOA.
Suck a toe.
SOHCAHTOA, is that what you went with?
Suck a toe.
4 over 12.65. I'm gonna leave it like that because if I put it in a calculator, I'm gonna have to round. Someone help me with cosine of theta and tangent of theta. What do we get for those?
Sine.
So.
Without the calculator, you don't need the calculator. Just what's the fraction answer? Don't give me some decimal bullshit.
Wait, just. I'm not understanding the question.
You. Using the triangle, because you weren't here for the first 20 minutes. Cosine, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. We have all of those 3 things, opposite, adjacent, and hypotenuse, from theta's perspective. What is the value adjacent to theta? Right. Adjacent means next to.
Cosine, it's 12 over 12.65.
Sorry.
Yes, it is. Thank you. What about tangent?
4/12.
It's opposite over adjacent, 4/12.
Yeah. Got that, but I didn't get it.
Good. Okay, so there are three new functions. They are pronounced cosecant or read as cosecant, cosecant. This is not really how it sounds.
Cosecant.
Let's do this, cosecant. Cosecant, cosecant. Then there's secant. And then there's cotangent.
Alright.
So we have three new ones. Cosecant of theta is abbreviated CSC. Secant is abbreviated SEC. And cotangent is abbreviated COT.
There's so much to go through.
Cosecant is hypotenuse over opposite, which is really just 1/sine theta. Yeah,
So you remember how I told you that if you were to do mode 2 times and then you would get like the other 3? Well, I found them, but they're in different types of. You know?
don't worry about that. Okay. Just put a cool cloth on your forehead and everything will be all right.
I don't know what either.
So cosecant of theta is really just 1/sine, which flips the fraction over. Secant of theta is 1/cosine, which flips over cosine's fraction. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. And cotangent of theta is 1/tangent of theta. So we flip over this fraction and we get adjacent over opposite. There is no rhyme or anything that goes with cosecant, secant, and cotangent. Ideally, you just remember that these are related. Now, it pisses me off because the letters are different. So the way I remember it is they both have one that starts with S and C. The sign points to the one that starts with the other letter. Cosine points to the one with the other letter when I do the upside down. So cosine goes to secant, sine goes to cosecant. It would be nice if cosine went to cosecant, but that's not how they fucking did it. So, those are the relationships. And oftentimes, a lot of calculators don't have these three. Do not have these three. So the way you get around that is, let's say you want cosecant of 30 degrees. The way you get around this is 1/sine of 30 degrees. So in a calculator, you hit 1, you hit divided by, you hit sine, you type in 30 and you hit equal. you should get cosecant of 30 equals 2. Assuming you're in degree mode. That looks like a 38 now. This takes some practice going through it. You'll get some practice for the test. I'm not going to ask you about cosecant, secant, or cotangent. I will more than likely ask you about the sine, cosine, tangent of a triangle. I wanted to do that when you were up here. I can teach you, all right? That's right. Little kisses at you. Oh, there's a little bite in that one.
So nasty, you don't understand.
I'm no if you're smelling it, I know it is. All right, so we can use this information to find other parts of the triangle if we don't have everything. So if we don't have all the parts of the triangle, can you smell anything? No, you can't.
She's like, ugh.
All the info for a triangle. We can use this info to get it. Use these equations to get it. You need 2 pieces of information. And one of them has to be a side length. If you just have the 2 angles that are not the 90-degree angle, there are an infinite number of triangles that have those angles that are just different sizes. So let's take a look at doing this. Let's do some examples, do a bunch of examples, and then hopefully it makes sense. Let's say I have the triangle. Actually, before we do that, I want to tell you one more piece of information. I'm still going to do the triangle. So that angle is 90 degrees. The right angle is 90 degrees. If I have angle A and angle B in here, the right angle is technically angle C. All 3 angles add to 180 degrees in any triangle. Which means in a right triangle, the 2 angles that aren't 90 degrees add up to 90. And I'll kind of show that. Angle A plus angle B plus angle C add up to 180 degrees. But angle C is 90 degrees. We subtract the 90 over. And I get angle A plus angle B equal 90 degrees. If I don't know what B is, but I have angle A, I can subtract angle A from both sides here. And I can see I get angle B equals 90 degrees minus angle A. So in a triangle, if this is theta, this is 90 minus theta. The equivalent in radians is pi over 2 minus angle A.
You guys got equations?
She just used that as an excuse to leave class for fucking 20 minutes.
She's like, oh.
Next time I'm gonna get up and I'm gonna blow one into her backpack. That way when she opens it, comes out.
Close it up, she opens it. There.
That's a little dirty. Fuck, I wish I thought of that earlier in the semester though. That would be great.
Surprise attack.
Right? She wouldn't notice it she wouldn't know for like an hour when she would put her shit away. All right, let's do some examples. We're going to use this to find all the angles and all the sides. So when we say solve a triangle, what that means is find all the missing angles and sides. There's some sick freaks in this world. Some pretty girl was making money selling jarred farts online. So she kept eating foods that made her very gassy so that she could make more money. I don't know who's buying these things.
She's actually saying.
She was selling them, but
She's like, this is
yeah, she said, this is me farting in a jar and people are buying them. I don't know how much, she made a lot of money until health issues arose because she was eating too many things that were making gassy and it did something to her innards.
Oh my.
But yeah, there are people that will buy a good fart.
No.
Look it up, Google it, buy a fart. I guarantee you. I think I'm making this shit up, but that's just too fucking sick to make up.
People are wild.
All right, let's look at a triangle. Let's look at several triangles and go about doing this process. So we're going to start off with this triangle right here. This triangle has 23 degrees there. This is a right angle. And we will say the hypotenuse is 12. That is our given information. So if I gave this letters, maybe let's give this letters. It's easier to explain shit if I give it letters. So basically, the given info is angle A is 23 degrees and the hypotenuse is 12. Let's go with 12 centimeters. Okay, so if you have an angle, it's easiest to find the other angle first. The other angle is 90 minus that. Which means here, angle B is 90 minus angle A, which is 90 degrees minus 23 degrees, which is 67 degrees. So I will pencil that in. The CM there like that. I'm penciling in the shit I don't know or that I determined using red. So that's 67 degrees. I recommend for the following, always stick with the angle information you know. I want to find out what sides B and sides A are. I don't know what those are. So we do have some equations though. If I start with 23 degrees, I am given with 23-degree angle. I am given the hypotenuse. And so to find B is the adjacent side, right? We're going to use that and go, which formula has adjacent and hypotenuse? So we go, okay, I don't remember that. Let's take a look. We have SOHCAHTOA. The one that has AH in it is that one, cosine. So what this tells me is the cosine of 23 degrees equals adjacent, which is B, over hypotenuse, which is 12 centimeters. I hate my B's look like 6s. So if I clear the fraction, fuck fractions. I'm going to multiply both sides by that 12. And I get B equals 12 times cosine of 23 degrees. And that's in centimeters. I don't know what that is, but I can calculate that. Times cosine of 23. B is 11.046. I'm going to write them all down. Centimeters. If I wanted to round this, I would say B is about 11.046 centimeters. Thank you. So that gives me B. And now if I want to find A, I have a couple options. The best option for A is to use the trig function that finds A. So for A, little a, which is the opposite of 23 degrees. I want to use opposite and I want to use hypotenuse. Opposite and hypotenuse go with sine. So we're going to go sine of 23 degrees equals opposite, which is A, over hypotenuse, which is the 12 centimeters. And doing the same thing, we clear the fractions. I get A equals 12 times sine of 23 degrees. And for that one, I'm getting 4.688773542. If I were to round this, I would say 4.689 centimeters. Now we have every piece of information about the triangle. Check it out. We were given 23 degrees here. We know that's a right angle, so we know that's 90 degrees. And we were given 12 centimeters there. We calculated this to be 67 degrees. We calculated B, which was down here, to be 11.046 centimeters. And we calculated A to be 4.689 centimeters. I have all three sides and I have all three angles. My angles, if I add them all up, I get 180 degrees. As every triangle has. And presumably, if I did not round, a squared plus b squared equals c squared. Our Pythagorean formula from Monday, 11.046 squared plus 4.689 squared should equal 12 squared. I know this side is 144. Let's see how close we get once we round it. 11.046 squared equals 122.014, and 4.689 squared equals 21.987. If I add those together, I get 144.001. So it's off because we rounded.
Just almost later.
Oh, fuck you up.
So yeah,
For real, it keeps rolling that way.
What way?
was it a big one?
I don't know, look like it did.
Oh.
Not cool. Is it near me?
I don't know, we're inside that hole,
What hole? This one?
that little.
I'm not standing on the
That one down there? Oh, fuck. Daddy long legs don't hurt you.
It's fine.
I'm glad you're
It's coming
paying.
out, it's coming out. Oh, look, it's right there, it's right there. It went under the thing.
I don't see it.
What thingy?
It went under the.
Can you quit derailing lecture? There's just one last lecture. We got 30 minutes left. It's a daddy long leg.
Okay, Hey,
If you said it was like a black widow, it looked like a black widow, this is something fucking different.
No, but it looks like either a daddy long leg or a brown recluse.
Oh my god,
Brown recluses don't look anything like a daddy long leg.
that's a stretch, right?
She's trying to derail my fucking lecture.
Yeah, I don't see no spider.
I'm calling bullshit on your ass.
The ground.
So this is different. Due to rounding. So the less you round,
Just trying to be a hero.
is that what it is? Hero is the word we're going with, the operative word. You're saving me from a daddy long leg.
Or a brown recluse.
Recluse, it's not a recluse.
Recluse?
Recluse, recluse. And they don't look anything like a fucking daddy long leg.
Not what it was.
They're like the tan color.
I would be surprised if there's a brown recluse in this building.
Brown zone.
Daddy long leg, really? Can you really see the color on a fucking tiny ass spider at this distance?
Well, I mean, it had long legs, so.
Was it furry? Then it wasn't, because you would have said, yeah, it's fucking furry. All right. Let me give you guys another problem to try while I load up on the screen the difference between a fucking daddy long leg and a brown recluse for Ari over here, so that she can figure some shit out and learn something today about animals. Let me give you guys a triangle to work on. We're gonna have I'll say that's 60 degrees. And this is a 6. Find the other angles and the other sides. Wow. Oh shit, it's coming out of the box. Drama club. I was telling other students about you this morning. I have this girl in class that likes to try to derail my lectures. I give her a couple minutes each day to do it. Just to let her be happy. And you got me all paranoid. I feel brush fucking hair and I punk ass.
Did you actually see me?
Yes, I did. It went under the dusting.
Look like the Chrome car machines.
I am.
Yeah, I don't see you looking at me and you're looking for the spider. Okay, do more than draw the picture. Try to calculate what we doing, what we just did.
Pretty sure it's dead.
All right, this is what the difference looks like.
Probably the
Daddy long legs, their legs are really fucking long. They tend to arc up in the air just like this. You can see other pictures where they do it, they arc up really high. Brown recluses are flat.
Okay, so it had to be a recluse then, because it
It
was.
was not a fucking recluse.
Recluses aren't even
It
that
was-
big though.
When it was falling down, it was flat, it wasn't like.
Or it just might have been another kind of spider.
Was it tiny?
No, it was pretty big.
Regions.
Most of the diagonal. Yeah,
I don't know. Maybe we do have some in the area.
Told you.
right there.
I don't think you saw one.
You went,
That's
I
what
don't
you
wanna
saw.
be- I don't wanna be a hero. You do what's on it.
I will. Check your backpack.
Oh, right, whatever you do.
Wow. That's fucked up. You know, it'll make me sick if it is a brown
That should
nose.
kill you, it's not like a black.
I'm a pretty big guy. It might take a while to kill me. That paramedics might be able to save me.
Chop your leg off.
The fucking or you fucking poison antidote. They tend to not come looking for trouble. It's not gonna come fucking scurrying out and bite me. It's not a fucking spider movie. It stays where it's at. They only bite shit that go into their area. I'm not in
As soon as
this
you
area.
brought up, like, it immediately just went straight down.
Okay,
From the hole,
So it crawled up to the hole. Then from there, when you got up, it was slowly going towards, and then it just went under. I was looking at it, but
under.
I was like, I had something, but then I looked, and I was like.
okay, back to the triangle. Your derailing is complete. Give you a few minutes, then we'll do it together.
Is it you?
Something. It's in the YC or YMC or something. Oh, sorry. He knows it.
Why do you think I've been to the YMCA? The fuck?
He's like, oh yeah, you see it, so maybe it's YMC. Yeah. Okay.
So looking at the spider,
No, I'm waiting for you to do the triangle.
I only found eight, but the,
What'd you give her A? If I could say 6, I'm gonna throw your ass out.
and I got 0.866, or I got 0.00174532.856.
I have no idea what you did, that neither of those sound right, so we'll check it out in a second. All right. So first things to do, it's kind of easy to find the other angle first. This angle and that angle have to add to 90 degrees. So like I can say angle theta plus 60 degrees equals 90 degrees. If I subtract 60 degrees, I get theta equals 30 degrees. That fills in my missing angle. For the rest, I'm going to label the points. We'll call this A, B, and C. And so this side over here is A, and this side over here is C. So if I want to find A, and I'm going to use angle B, because that's the one I have. Generally, this case, 30 degrees is pretty easy. There's no rounding on the 30 degrees. So I could use either. But as you'll see in a second, we're going to end up rounding pretty soon for these angles. It's better off to use the angle you start with, which is the one you know is accurate. So use the starting angle. Which is 60 degrees. The other piece of information we have is the opposite side of the opposite of 60 degrees is 6. Maybe I should give it some units. Let's call it centimeters. Centimeters. So I want to find A. A is adjacent to the 60. So I am looking for something that has opposite and adjacent in it. Opposite and adjacent, if we have SOHCAHTOA, the one that has an O and an A, opposite and adjacent, which is the TOA, which is tangent. So tangent of theta equals opposite over adjacent. The pieces of information I have is the angle is 60 degrees. The opposite is 6 centimeters. And what I'm looking for is A. So first off, I will clear my fractions. I'll multiply through by A. And if I do that, I get A times tangent of 60 degrees equals 6 centimeters. And finally, I'll divide both sides by that tangent of 60 to get A by itself. And that's calculator time. Six divided by tangent of 60. I'm getting 3.464 to 3 decimal places. And that's A. So I needed that one. What?
This way all.
And then I want C. So for 60, I have 60 degrees. I have opposite, which is 6. And I want C, which is the hypotenuse. I want the one that has O and H in it. This is the SO one. So sine of 60 degrees equals opposite over hypotenuse. If I clear the fractions, I multiply both sides by c. I get c sine 60 equals 6. And then I'll divide both sides by sine 60. And I get c equals 6 centimeters over sine of 60. .928 centimeters. So going up to the top, I can fill in the missing things that I had. A was 3.464 centimeters. And C was 6.928 centimeters. And I have solved the triangle. So overreact, held back this time. Just an eye roll this time. She's trying, I know she is. I'm really looking forward to when you open that bag. It's gonna be glorious when you open that bag. Because you foolishly left your bag unattended in a room with a guy that likes to fart. What could a guy that likes to fart do with that information? Make sure you inhale deeply when you open your backpack.
Hey, I told, I just said, I'm the water one. I don't like that, so. Yeah, you're in the class, I was gonna water out.
It's at least his backpack. I didn't do it into a water bottle or anything like that. That'd be foul.
Also, I have. OCD and I need that. And it's not touch because it's not the book, and so then flip over and other things will go over, but see.
Okay, don't believe me.
You,
Then inhale deeply when you open your backpack. That's all I'm saying.
but
Me, open the backpack, it's for you, it's your backpack.
Let's do another one.
Ready?
don't
Nah,
let's.
this way, Greasy.
We're gonna have 1.9 and we're gonna have 12.
He's like, I'm British.
So let's call this A, B, and C. And so we're looking for angle A, we're looking for angle B, and we're looking for little a. Because we know this is 90 degrees here. Okay, so. Couple fun things we can do. I have two sides. I can get the third side using that Pythagorean formula. So with two sides, find third with Pythagorean formula. I want you to rewind, go watch this video later on when it's posted. Just rewind it and look, watch what happened to your backpack.
Yeah, at least you give me that.
Oh, yeah.
In this problem, A is this one, B is the side opposite of the angle B, and C is that. So I have a squared plus 1.9 squared equals 12 squared. So if I square 1.9, I get 3.61, which feels wrong. That's what it says. And 12 squared is 144. So if I subtract that over, I get a squared equals 140.39. This is where we need the square root stuff. A will be the square root of 140.39. And let's just see what that is. I'm getting A equals 11.8486. Whatever units they're in, I didn't write a unit.
They're biting.
What the fuck is wrong with you? I just scratched my leg and all of a sudden she wants the fucking spider to bite me again.
There's webs under that too.
I bet there is spiders under there. I don't think it's a brown recluse. But I will notify them that there's spiders underneath there. Students notice the spider and are freaking out. I'm gonna say they're freaking out. There's a brown recluse. So can we please have the area like
Pest control.
pest controlled so that my student can come to class on Monday without fear of being attacked. I will email today. Okay?
Thank you. Appreciate it.
You're welcome. I do that for you. All right, so now I want to find angle A and angle B, and I want to use the information that was given. Use given info. So if I want to find angle A, B equals 1.9 is adjacent. And C equals 12 is hypotenuse. If we go with our SOHCAHTOA, this is cosine. Cosine of A equals adjacent over hypotenuse, which is 1.9 over 12. Which means A equals cosine inverse of 1.9 over 12. So this is where you got to do that shift function. Just do it. And put it up there while you guys are writing. I have A is approximately 80.89 degrees. I could do something similar to find B using one of these trig functions, or I can say A plus B has to equal 90 degrees. So B equals 90 minus A, which is 90 minus 80.89. So B equals 9.11 degrees. And now I have all three sides and all three angles. I didn't have to find angle A first. I could have started off finding angle B first, If I wanted angle B, if I went with B. B is doing opposite an hypotenuse. So this would have been sine. Sine of B equaled 1.9/12. So B equals sine inverse of 1.9/12.
I just got it.
9.11 degrees.
I got it.
You got it? Is like the answers? Is that what you're talking about? What do you mean you got them?
So we castrated a.
Pictures of what? His nuts? What do you mean? What do you mean you have them?
They show me first.
What is them? I don't know what them is. I really want to see this.
Yeah, I don't want to see.
All right, come derail the lecture for one more minute.
Oh, that's great.
That was pretty feminine. You're gonna make me watch him do it?
Yeah.
I thought you were just gonna.
Wait, what?
This poor motherfucker. She's teabagging that horse.
Oh, yeah.
Dip. How long is this video? I said you could derail it for a minute.
That poor horse.
Okay, I'll just show you.
So that's right.
Yeah, I really don't want to see the fucking. Yeah. When I fucking see that. That's again a fucking video, really? Oh, that poor guy.
And then,
Damn. I don't know how big that is though.
I don't know, they were pretty small, actually.
Okay. Well, thank you for sharing with me castrated full testicles. How old was that poor horse?
He was a yearling.
Yeah, that's fucked.
He was still, he's just like he was aggressive.
Can you justify removing anybody's genitalia for any reason whatsoever?
Yes,
You're wrong in the head.
I can.
Wait, why do you do it?
Behavioral issues, especially if he's gonna be a show horse or if he's gonna be,
So he nips at the rider, so they're like, no, fuck you, we're cutting it off.
exactly.
Really?
It can be very dangerous. You can be.
Okay, so you don't ride the horse.
That's not the point.
Yeah. I know, it's abuse the animal. You don't think it's abuse?
I think all.
You think the animal like, wow,
The geldings,
Um,
they're gentle.
I'm pretty sure you don't know how reproduction works.
Yeah.
All right, you're done with diverging my shit. I got a couple topics I need to say. So we covered different ways to do triangles and find the missing parts. If you are standing here and like this is your like the flat ground, like that is looking forward. And you're looking at something up here. This is your line of sight to target. This here is called the angle of elevation, or sometimes you'll see inclination, but usually not inclination. Usually it's just the angle of elevation. How far up, how elevated is the thing you're looking at? If you're looking at something that's below, like let's say you're fucking standing on a hill and you're looking at something down here. This angle right here is called the angle of depression. Or
Already there.
declination. Declination, which is like decline or goes down. Inclination is like incline.
Like a decrease.
Yes. Decline is decrease. So it's like, how much is it decreasing? Stuff like that. Damn, I really wanted to do that problem and we just didn't get to it. That would have been fun. All right. So like something like this is, let's say a jet lifts off at a 30-degree angle with 980 feet of runway left. What is the jet's altitude at the end of the runway?
So are you saying that the ground level would be?
So I'm saying like, here's the runway. This is the point where it starts, the wheels lift off.
Yeah.
So lift off is here. And it's flying at an angle that is 30 degrees like that. And so here is the end of the runway. From here to here is 980 feet. And we want to know, here's my plane. How high up is that plane at the end of the runway? What is the height or altitude? Pew, 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 pew. It's a fucking cheater jet. All right, so I'm trying to find this side. I have this side and this angle. So in relation to this angle, this is the adjacent side. And this is the opposite side. So if we look at SOHCAHTOA, I have A, I'm looking for O. That's going to be that one. So tangent of 30 degrees equals opposite, which is what I'm looking for, over adjacent, which is 980 feet. If I clear fractions, multiply through by the denominator, I get the opposite side, which is also my height, is 980 feet times the tangent of 30 degrees. And this becomes calculated. This is about 565.8 feet. And that will be all for today.
And it was only going 30 like degrees.
30 degrees, but it was over 980 feet, which is a long ways.
So Monday's review.
Monday, we're going to do a review. I should have up the practice exam by tomorrow morning, hopefully. And so try to work on it over the weekend. It will have some of chapter 19, not a lot. 17 and 18, and then a little dabbling of here and there from the previous chapters. So similar to I like took problems from the previous example. I'm going to change the numbers. Certain times of ones I think are worth doing. And I will see you guys on Monday. And I need to remember to write it, email about this route.
Bye, John.
See ya.
Bye.
What's up, Bertha?